Okay, today's lesson is going to be over section 7.2, solving systems of equations by substitution. Okay, the first problem we're going to do is a story problem. Flying to Kampala with a tailwind, a plane averaged 158 kilometers per hour. On the return trip, the plane only averaged 112 kilometers per hour while flying back into the same wind. Find the speed of the wind and the speed of the plane in still air. So it asks us to find the speed of the wind and the speed of the plane. So speed of the wind, speed of the plane. These are our two things that we're trying to find here. I'm going to represent the speed of the wind as x, and I'm going to represent the speed of the plane as y. Okay, so let's go through and let's think about how we can set up a couple of equations here. Because we have one equation that will be set up for the 158 kilometers per hour, and we have one equation that will be set up for the return trip, which was the 112 kilometers per hour. Well, on the first trip, it said that they had a tailwind. A tailwind means it's pushing you from behind, which it's increasing your speed. So that means the speed of my plane, y, plus the speed of the wind should equal my total speed, which is 158 kilometers per hour. And then on the return trip, it said I only averaged 112 kilometers per hour, but I was going back into the same wind. So I'm going into the wind now. Whenever you go into the wind, it slows your speed down. So the speed of my plane, y, is being slowed down, so it's losing speed, so we're going to say subtraction. So the speed of my plane minus the speed of the wind is actually how fast I'm going. This comes back to if you run track, you're out on the track and you're running one direction and the wind's behind you, you run faster, but if you run in the other direction, you're running slower because the wind's pushing you and it's harder to run into the wind. All right, same type of thing with this flying of planes. So we set up the two equations. This is actually the new method we're about to use here. So typically what we have done before is we graph this equation, where they intersect, that's our solution. Now we're going to do something called substitution. And substitution means I solve for one of the variables. I can either solve for y or solve for x in one of the equations, and then substitute it over into the other equation. Alright, so let's go ahead and look at this. I want to solve this equation, and I'm going to solve this equation for y. To do that, if I want to solve for y, I'm going to subtract x to the other side. So that's y equals negative x plus 158. So what that says is my y variable here equals this expression. Right? This is what y equals. This side here is the exact same as y. So what I can do is I can plug, just like I would a number if I'm checking a solution, I can plug this in here for y. So I'm going to take this whole thing right here and I'm going to plug it in for y there. Let's see what that would look like. And when I do that, I always put parentheses because I'm replacing it where the y is. So I got a parenthesis, negative x plus 158 minus x equals 112. So you can see I just took this because it equals y and I put it in for that spot where y was. And now I only have one variable. All right, the problem before I had two variables and one equation here. So now I only have one variable in this equation. I can solve for x. Distribute this 1 that's out front here. That's not going to change anything, so it's negative x plus 158 minus x equals 112. Combine like terms. Negative x and negative x is negative 2x plus 158 equals 112. Let's subtract 158 from both sides. 112 minus 158, that gives me, what, a negative 40, a negative 46. So negative 46 is on the right side equals negative 2x. Divide by negative 2. So x equals 23. And our label here is kilometers per hour. So 23 kilometers per hour. And remember, x is the speed of the wind. So the speed of the wind is 23 kilometers per hour. Now we can take this and plug it back into either equation and figure it out. All right, let's use this equation right here. That would be y minus, we're using this equation, 23 equals 112. Add 23 to the other side. So y equals 135. So the speed of the plane was 135 kilometers per hour. And the speed of the wind was 23 kilometers per hour. All right, we think this is true. Let's check it to make sure. Well, let's use this equation. 135 goes here. 23 goes here. 135 and 23, 158. 135 goes here. 23 comes here. 135 minus 23, 112 kilometers per hour. So this is how you solve an equation, or solve a system of equations using substitution. I actually like this method a lot. I think I like it better than graphing. When you get decimals or fractions or things like that, it's easier to see and it's easier to figure out the answers using substitution than it is when you're graphing. Let's look at another example here. Now we're going to get away from the story problem. We're just going to practice the substitution method. So I've got two equations, one here and one here. All right, I want to solve the linear system using substitution. That means I just need to take one of these equations, either one, doesn't matter which one, and solve for either x or solve for y. Well, in the last problem I solved for y. If you remember, I solved for y. So this time I'm going to solve for x. To solve for x, I'm going to add y to both sides. That gives me x equals y plus 3. What that tells me is x is literally equal to this y plus 3. This expression is the same as x. So I'm going to take it and I'm going to plug it into this equation for x. All right, take y plus 3 and plug it into this equation for x. So that gives me y plus 3 plus 2y equals negative 6. Now you notice I put parentheses in there because I'm putting it in for where x was. The parentheses in this case don't matter because we're distributing a 1. So that will just give me y plus 3 plus 2y equals negative 6. Let's combine like terms. We've got a y and 2y. That's 3y plus 3 equals negative 6. Then we can solve for y now. Minus 3, that's 3y equals negative 9. And divide by 3. So y equals negative 3. So the y value here equals negative 3. Let's check to see what x is. We can plug this into any equation, either this one or this one. It doesn't matter. Let's go ahead and plug it back into this original equation here. So we'll say x minus y equals 3. So that's x minus, and they said y, x minus y, so this is x minus negative 3 equals 3. Well, two negatives make a positive, so that's x plus 3 equals 3. We subtract 3 on both sides. X equals 0. So what that tells me, that's my solution. X equals 0 and y equals negative 3. Remember, when we have graphing, wherever they intersect, that's the solution. So it's the same thing here, all right? Our solution is 0, comma, negative 3. But we're not sure if that's for sure. We want to make sure that that's right. So let's plug 0 in here and negative 3 here. So 0, and that'll be a negative and a negative. Gives you a plus 3, so that's 3 equal 3, so that works. We plug 0 here and a negative 3 here. That gives us 0, and then 2 times negative 3 is negative 6, so negative 6 equals negative 6. So it works. It's good. This is our solution. Let's look at one more example. We got two equations, one here and one here. I keep doing the one on the left side. I've done the one on the left side a couple times. I'm going to come and I'm going to start with this equation. All right, and last time I solved for x. All right, this time I'll solve for y. All right, so it doesn't matter which one you do. You just get a pick. In this equation, I'm going to solve for y. So I'm going to add 2x, add 2x. So that's 4y equals 0 plus 2x is 2x. Now I'm going to divide by 4. 2 divided by 4 gives me a fraction, so I have y equals 1/2 x. So this side is equal to the y. Y is equal to 1/2 of x. So we're going to take that and we're going to plug it in. We're going to plug it in for y. So when we do that, that's going to be 3x plus 1/2 x equals negative 7. Now again, I put the parentheses because I'm substituting in for y, but in front of these parentheses is just a 1. So it's not going to change anything. So it's really 3x plus 1/2 x equals negative 7. 3x plus 1/2 x, that's 3.5 x's. So let's find a common denominator here. I think that'd be best. So this is over 1. We multiply it by 2 on both the top and the bottom, and that gives us 6 over 2x plus 1/2 x. All right, just find a common denominator between the two. 6 and 1 is 7 over 2x, and that still equals negative 7. Now we want to get rid of this. All right, you can either multiply by the reciprocal, or you could do it step by step. I'm going to do it step by step. I want to cancel a fraction. I multiply this whole thing by 2, so that gets rid of the 2 here, so I have 7x. And remember, I multiply it to both terms, and that's negative 14. Now I can just divide by 7, and x equals negative 2. So I think my x value is negative 2. Let's plug that into an equation and find out what y is. So I use this here. Let's go back up and let's use this equation here and find out what y is. So 3 times negative 2 plus y equals negative 7. Well, 3 times negative 2 is negative 6 plus y equals negative 7. Let's add 6 because it's negative to both sides, so y equals negative 1. We think that our solution is negative 2 for the x, negative 1 for the y. We just have to check to make sure that this is true. Let's check this equation first. Negative 2 goes in there, and negative 1 comes in here. So negative 2 times 3 is negative 6. All right. Negative 1 in for y, so it's negative 6 minus 1, which is negative 7. That works. Let's plug negative 2 in here. Negative 1 here. Negative 2 times negative 2 is a positive 4. 4 times a negative 1 is a negative 4, which 4 minus 4 we know equals 0. So this is our solution. So that's solving systems of equations using substitution. I like it a lot better than graphing, like I said. Make sure you took the notes. Make sure that you turn them in tomorrow. And if you want to take a look at the U-Try problems, go ahead and do those as well.